This is unSILOed, brought to you by Alumni FM, connecting people through stories.
Welcome to unSILOed. This is Greg LeBlanc, and I'm here today with Philip Ball, who is a freelance writer. And I mean, talk about unSILOed. Philip, you've written on a wide range of topics. I have a subset of your books here with me. I have this old one. It's called Shapes, which is, I think, one of a trilogy all around patterns. Got this one. I don't think I'm doing this in any particular order. It's called Invisible, the dangerous allure of the unseen. We've got this one called The Music Instinct, how music works and why we can't do without it. This one, Curiosity, how science became interested in everything. Bright Earth, art and the invention of color. This one, Critical Mass, which is, I think, the first book of yours that I read, which I devoured in like 2 sittings. It was really super interesting and set me off on all sorts of curious directions. And most recently, this book called The Book of Minds, how to understand ourselves and other beings from animals to AI to aliens. Welcome, Philip.
Thank you. Thanks for having me, Greg.
Well, as I said, I think, you're incredibly unSILOed. And, as a freelance writer, it seems like you have the ability to range across all of these different domains in ways that you would probably find difficult if you were an academic. And so I was wondering if you could talk a bit about, what being a writer allows you to do. I mean, some writers are sort of at the mercy of commissions, right? They have to do, somebody contacts them and says, hey, I need you to do a piece on this. And I think you mentioned in Book of Minds that came out of, right, kind of a commission that was given to you. So, how do you decide what topics that you're going to do these deep dives into, and how do you get the freedom to do this kind of inquiry?
Well, it's funny you should ask that, because just yesterday I was at Oxford University. I was visiting there with my daughter, who's wanting to apply, which is very exciting. And it set me thinking about that same issue, because I trained at Oxford originally as a chemist. And, it made me realise that had I stayed in academia, which I could have done, there is no way that I could have written about this variety of topics. And in retrospect, it was clear to me that the reason I left was because I didn't want to stay siloed, as you say. And I guess what really motivates and interests me is to take a subject where it needs to go. And I think that's something that actually one does find very difficult in academia, because, if you're in a physics department, which I was subsequently, then you're meant to stick with the physics of what you're writing about. So, for example, with the book Invisible, part of what stimulated that was recent work that has been done on things called metamaterials, which are materials that are able to manipulate light in unusual ways that you can't do with lenses or so on. And they've been used to make what the researchers are calling invisibility shields. And they turn out to be not quite what you expect that to mean, because this is an invisibility that works at sort of microwave wavelengths or radar wavelengths. So you can see the thing you're hiding inside the shield, but you can't see it with radar.
It's not a ring of Geiges, right? You can't
exactly.
You can't just, go and
yeah. But it's fascinating work. It comes out of physics, comes out of physics ideas, but it occurred to me, that if I was going to write about this topic, I couldn't limit myself to optics and physics and metamaterials, because the notion of invisibility, it's a cultural notion, and I really wanted to explore what culturally we've done with that notion. And it does go back to Plato's ring of Gyges, which is the kind of the original invisibility ring that we now have in Lord of the Rings and so on. And Plato's point was that if you had this ability to become invisible, it would inevitably be corrupting. You would be able to evade all responsibility for your actions. And what happens is that Gyges, this shepherd, finds this ring. He finds it sort of underground. The ground splits open. He goes down into the underworld, finds the ring, finds that it turns him invisible. And the first thing he does is he goes on a deputation to the king of his country. Kills the king, steals his wife, and sets himself up as ruler, all through the power of invisibility. And Plato's point was, if we had this power, which of us would not do the same thing? How could we possibly resist that urge to use it, for our own purposes? And that was really the point that H.G. Wells was making in The Invisible Man, the book that he wrote at the end of the 19th century. It was really a rewriting of Plato, but using science, using the science of its time, which included, X-rays and electromagnetism to turn invisible. And that was really what I wanted to explore in this book. How is that idea of invisibility being used culturally through times, for example, in the Renaissance, when there are all kinds of recipes you can find for magical recipes for how to turn yourself invisible, through to things like H.G. Wells. It included things like fairy tales, where invisibility again crops up with a specific purpose very often. I looked at ghosts and the supernatural. I looked at the way Shakespeare uses invisible ghosts in Macbeth, for example, to question what's going on in the mind and challenge the psychological narrative of Macbeth. So that was where that story required me to go. And, as I say, you can't do that in a physics department. And I think that's really what I've alighted on doing in my science writing. I figure that I have what is really a tremendous privilege to be able to take, a couple of years or so to really delve into a topic that I choose that just sort of arises, and to be able to do that in a way that doesn't need to respect disciplines, not just scientific disciplines, but academic or intellectual disciplines generally. So, it can mean going into myths, it can mean going into literature as well as going into what's happening at the forefront of science. And that is really what keeps me doing what I do, certainly in terms of books. And books allow you to do that in a way that commissioned articles don't. I do journalism as well, and sometimes that's commissioned, but it's really the books that allow me to sort of pursue those threads wherever they need to go.
Yeah, I forgot to mention you actually wrote a book on modern myths, right? A couple other books. You wrote a book on the history of physics under the Nazis. You wrote a book on the history of China, right? Which I guess is a sequel to your book on water, which I think was your first book. But there's nothing to prevent a physics professor from writing, say, that book on invisibility, particularly if they have a tenure or they're emeritus. But we don't see them typically writing those kinds of books. So it's not that they don't have the institutional freedom or flexibility. Is it more that by the time you get to be tenured and you have that kind of flexibility, you've either lost the capacity maybe to do that kind of interdisciplinary work, or is it just that you are still pursuing the esteem of your colleagues and you're not going to get that from that kind of work? I mean, why do you suppose academics sort of continue to be so specialized even when they don't have to be?
Well, I think it's a combination of things, some of which you've mentioned, Greg. So, the very much the message that one gets in academia is stay within your tramlines. And there are good reasons for that, because occasionally when you see scientists step out of them, and perhaps most notoriously when physicists, they have a tendency to think they can explain everything else in the world as well. So they come into biology and they say, well, look, we're going to clear it up for you guys, what's really going on. And it it doesn't have to be, but it can end up being extremely naive, biologically naive, because they don't have mastery of that area and they overlook a lot. And, that's, of course, always the danger in stepping into one of these areas that is extremely cross-disciplinary. You can really put your foot in it and overlook important things. And, I that's a risk I'm constantly running, which I hope I can at least to some extent negotiate by making sure that I consult with specialists in a particular field. For many years, I was an editor at Nature, the science journal, and I think one of the things that taught me was how to find the real experts in an area. And, particularly in science, scientists are incredibly generous with their time and advice. If you, approach them and say, look, I'm interested in writing about, this topic that you're working on. Of course, they're always interested to be able to talk about their work and to have someone write about it so that others know about it. But it's also just, I think, you mentioned curiosity. It's their natural curiosity, their passion for what they're doing that makes them very eager to share their knowledge. So, everything I do relies on that generosity that experts have. And I think it's something that I think in science we can sometimes take for granted. It's only when I've started branching out into areas of humanities that I realised that culture of being very generous with your time and your expertise isn't something that happens in every academic discipline. I'm always I always celebrate that, and I always respect and am thankful for the fact that scientists will do this. So that's really, the way that I will try to avoid that pitfall that academic specialists might have of, when you step outside your field, you risk putting your foot in it and saying dumb things. I think there's also, there's also the pressures within academia to succeed in your field, and I think this is something that young researchers increasingly feel, that they simply don't have the time to even read broadly within their own discipline, let alone outside of it. The literature is so vast, but the pressure also to make your mark in often a very narrow area of research is so great that they just don't have the opportunity to do that. So yeah, I think, in one way or another, the pressures that exist in academia militate against having this sort of breadth, and it tends to be something that scientists feel able to do, if they're so inclined, only towards the ends of their careers.
Well, do you think it's possible to be an expert generalist? In other words, is there a particular skill that enables one to get up to speed quickly on an entire domain? I teach MBAs, right? And MBAs are sometimes, they're very confident people, but they're also kind of insecure people because they don't have any in-depth expertise in any of the, not only of the domains that they work in, like accounting or marketing or whatever, but they also don't have any specific industry expertise. And they may wind up, running a consumer products company and then running a tech company and then running, like a marketing company. And they have to be able to kind of hop from job to job, and particularly like if you're a consultant. And so I think that, journalists like yourself, you seem to be an expert at acquiring new knowledge, compressing it, and then kind of recombining it and telling a story around it. And this is a skill which, a lot of people don't have. So, is there such a thing as an expert generalist?
I'd like to think so. I think it is a skill, and I think it's one that one can acquire. And for my part, I think that a big part of acquiring that was what I had to do as a Nature editor. These days, Nature is a publishing empire, and it has an ever-growing list of journals that it publishes. When I joined, which was in 1988, it was still Nature the journal. It was a single journal. It published across all areas of sciences, and it had a very small staff. I was one of four editors who handled all of the physical sciences. So, there was one who handled all of astronomy and cosmology. My area was pretty much all of physics, all of chemistry, material science, some biophysics. And that meant you had to get pretty good at getting up to speed very quickly. You never knew what was going to come in from week to week. And if one of my colleagues went away on holiday for a week, I might find myself handling papers on earth and atmospheric sciences instead, and so I'd have to do the same there. So it was something that I had to learn on the job, how to do this, how to assimilate enough knowledge very quickly that at least you had some orientation. Of course, one was never going to get the depth of knowledge needed to really assess what had been done in a paper and what the significance of that was and what the potential flaws of that were. But that was the job of specialist referees. That was what we had to find these people to send the papers to. But what we did need to be able to do was to get the broader picture, to figure out where at least this particular paper was situated in the sort of in the scheme of what had been done before and where this might advance the story on. So yeah, it is a skill to be able to do that. But I guess I think it's also there's also something about wanting to get that broader picture, about wanting to understand how things relate to other things. And I think that's something that started to become clear to me once I'd been at Nature for long enough, that I started to think, hey, you know what? Here's this paper that is claiming this. That sounds very much like this paper that I've just been handling in a completely different area, in biophysics or something. Maybe, is there some connection between them? And that's really what interests me. And I think that what's been really gratifying about the writing that I've done is that I do get some sense that scientists who again are necessarily having to keep quite a narrow focus in order to get on in their field, that they do seem on the whole to really appreciate these more general pictures, these works of synthesis, I guess, which they don't have time to attempt themselves very often. So you mentioned the book Shapes, part of a trilogy on pattern formation. That was really one of the first books. It was that they actually came about as a sort of rewrite of a book that I wrote in 1999 called The Self-Made Tapestry, which was about pattern formation in nature. And I started to notice as a nature editor that we'd get these papers that described patterns they might be in geology, they might be in developmental biology, they might be in astrophysics. Often they were the same kinds of patterns. There might be spiral forms, there might be sort of reticulated net-like forms. The question then arises, is that just coincidence, or are these all arising for basically the same rule? Are they all described in some sense by the same mathematics? Very often that did prove to be the case. So that was an area where the topic itself did range between disciplines, and it seemed to me that what could be really useful, and I hope it has been, is a book that tried to bring them together, to try to say, hey, what you guys in developmental biology are trying to understand is the same as what these people in condensed matter physics are doing. You're looking at the same phenomena. So yeah, that's really very often what I've tried to do with these other books, to point out the similarities and the relationships between fields that might otherwise seem to have nothing to do with one another.
Well, and I think you do that in Critical Mass also, right? Because it's a book about complexity, right? Which appears in, natural sciences and the social sciences. And, I think the focus is mainly on the social sciences in that book. But, do you find that the folks who read these books are not just the outsiders who are trying to make sense of these domains, but the people in the trenches? And are they able to then go and maybe develop their work with these additional insights? Are you kind of providing them with a bit of a periscope that allows them to see outside of their trenches? Just because in academia, I'm in a business school and we have marketing workshops and economics workshops, and they're, in adjacent classrooms, and, the faculty member is just too busy to even, step over there, much less to step over into, some of the natural sciences departments. So, do you find that you are able to get the folks who are in the trenches to, look outside by reading your work? In terms of the reception of your work, do you find that it's people who are participants, the kind of people that you study, or are they more like people who are outside trying to make sense of what's going on in these disciplines?
Well, it does seem to be both, but there's nothing more gratifying than to be told, and I have sometimes been told with critical mass actually, and also with the books on patterns. I've had people. I mean, I've been doing this for long enough now that I've had people who now are distinguished academics who say, well, I got into this area because I read your book on pattern formation, and thought, what a neat thing. I hadn't really thought about my topic in that way before. That's so lovely to hear. It's it's not often that you do, but when you do it, it makes it worthwhile. But I think what also the specialists seem sometimes to really appreciate is to see some of the intellectual background of their field, which is something that in science is often not really taught. You're taught, here are the mathematical tools to solve this particular problem, and you just use them, and that's what I did when I was a scientist. But you're not necessarily taught where they come from, what their pedigree is. So in critical mass, it was a book that was looking at how ideas that were developed in physics, in condensed matter physics, in statistical physics, for understanding things like gases and liquids and how they switch between the two forms, the things called phase transitions, how those ideas are now proving useful for social scientists, because we can find some situations where people en masse, taken in a large enough body, large enough numbers, they show the same kinds of behaviours. One of the most obvious, striking examples and familiar ones is road traffic, where you can develop simple models of road traffic that treat the vehicles as just particles that interact by forces, particularly forces of repulsion that prevent them from colliding. And of course, what that really is drivers will slow down so that they don't drive into the person in front. But in effect, what it looks like is that there's a repulsive force keeping them apart. So you can use the models that physicists have developed to understand systems like that, and you can see road traffic undergoing phase transitions, as if going from a gas-like state where everyone is moving, pretty much how they want to, independently down the road, to a liquid-like state where there are correlations between the way they're moving, even though they're still all flowing. Once the traffic density gets to a certain level, and then ultimately, you can guess what's happening probably, that you go to a solid state, you freeze. The traffic liquid freezes into a jam. And there are complex phenomena that go on in traffic jams. It's not always as simple as that can be understood using these kind of physics-based models. So anyway, that was what what critical mass was exploring. But what I realized as I was researching this and the history of this is, first of all, how important the rise of statistical thinking was in the 19th century, 19th century science generally. The idea that you could use statistics to understand systems where you didn't know everything about what was going on in them. They were kind of particles, but you didn't know what all the particles were doing. So you could describe them statistically and get a long way by doing that. And that was something that happened in many areas of science during the 19th century, including biology. But you could look back even further, that actually this idea of developing what look like to us today like physics-based models of social phenomena, of people, of how they behave, you could find the germ of that idea in the English philosopher Thomas Hobbes' work in the 17th century. And Hobbes, his most famous book was called Leviathan, and he wrote it. He began to write it during the approach to the English Civil War. And Hobbes was a royalist, so he was on the side of the king, but he was very worried that there was going to be this chaos, this instability, and he thought, how can we find the best way of governing society? And he created what is the equivalent of what scientists would now call an agent-based model of, a model based on how people interact with each other to try to work out what is the best mode of governance. And in Hobbes' case, it wasn't very encouraging. That basically he said you have to elect a leader and then make that leader essentially a kind of dictator, and you just have to follow that leader, and that's the only way that you can have a stable society. So it was a very good argument for the monarchy as a sort of source of supreme power. But you see, that distant history of this field was something that, I mean, I certainly didn't know, and I studied this area of physics, but physicists didn't know that, and I found them to be very receptive on the whole and very interested in the fact that there is that intellectual pedigree to what they're doing that goes way beyond what they're taught about the science.
Well, and in your most recent book, I mean, you go back and talk about like La Mettrie and Hume and Descartes, and most AI researchers probably don't spend a lot of time thinking about their predecessors. Maybe they think about Babbage, right? But I'm sure they would be curious to read that, of course. But when I was reading your book, Bright Earth, you described how your experience of a museum changed after learning about the physics of, or the chemistry of color and paint and so forth. And I was wondering, I mean, it seems like your experience of the world is enhanced the more knowledge you have, right? And that knowledge makes your life richer. So, I mean, is this something that you think people can model after? I mean, is this sort of is there a virtue associated with this curiosity? I mean, in the book Curiosity, you talk about how, there was a big debate about whether curiosity was a virtue or a vice, right? And at some point we kind of settled on the idea that it's a virtue. To what extent should people cultivate their curiosity?
Well, I'd certainly hope that some of the things that I can say will encourage people to do that, because yeah, absolutely, as you say, Greg, this is what I found for myself, that the more I understand about any of these areas, the more richness I can see in them, the more I get out of them. So with that book, Bright Earth, that came about, and sometimes this is how books happen, it came about because of a lecture that I went to by a chemist at University College London called Robin Clark, who used to do some work. Robin died some years ago, but he used to work with the British Museum because he was a spectroscopist, which is a technique that chemists use to figure out what stuff is made of, and he used that technique on paintings that were kept there, so he would be able to figure out what pigments were in there, and it sounds crazy to me now, but at the time I kind of thought, well, you know what, I'd never really thought about that. We take for granted all of these colours that we can go into a colour shop, into a paint shop today and buy, and we don't think, where do they come from? What's in them? How long have we had them? And the more I looked into this question, the more it became clear to me that the whole history of art, one way of telling it could be through the medium, the materials of art itself. How do artists get their colours? Where have they come from? What colours have they had in the past or not had? It's clear that there are a whole range of colours that artists have today that simply weren't available to Rembrandt or Titian. So what did they do? Well, they had to mix them, and sometimes that doesn't give you good enough colours, and so they made different choices for their palette. But also they had to buy them, or their patrons had to buy them, and they're expensive. And some of the colours that were used in the Renaissance, I mean, most famously ultramarine, this wonderful lustrous blue, it cost more than its own weight in gold, because it was made from a mineral called lapis lazuli, which is this wonderful blue mineral that at that time was known in only one place in the world, in remote mines in Afghanistan, in a region called Badakhshan. So it had to be it had to be mined there and then shipped ultimately to Europe at fantastic expense. Even then, that's not the end of it, because actually extracting the blue pigment from the raw mineral is quite a complex process. And, that took a lot of time and it increased the cost. So painters would only use ultramarine if they had a very good reason to do so, and if they had a wealthy enough patron who they could persuade to pay for this colour. And so they tended to use it in the most sort of illustrious or the most precious contexts. The most famous of which is the blue robes of the Madonna, of the Virgin Mary. And so that was the colour that Mary is painted in most Renaissance works. Not because, as later art historians sometimes said, blue symbolises humility or virtue or whatever, but because it was the most precious material. And so using that for the most holy aspect of the painting was a way to make that painting serve God more clearly, more explicitly. So that's an example of how we only really understand what is going on in a painting if we understand something about the materials that it's made from. And I found, until that time, until I wrote this book, there were plenty of paintings that I love to go and see in the art galleries we have in London. But the whole of the medieval and the Renaissance section of the National Gallery, and there's a lot of stuff there from that time, and it was a closed book to me because I didn't get the classical references. The style wasn't something that I really responded to. But once I had this window on that art, once I looked at it and I thought, you know what, that is Red Lake. That is Carmine Lake that is being used there. That yellow is orpiment, which again is a very rare and precious pigment, and also a poisonous one. So a lot of painters tended to avoid it. And then you start thinking about how did they get those materials? Why did they choose to use them there? And it's a way into the art. And now, that's I love that era of art. So that's a perfect example of how looking into a subject through a window like this, and there are others, was it opened my eyes, literally to what was there to be seen, and it enriched and deepened my experience of the world and the things that we make.
So does knowledge just improve and enrich your experience? I mean, or are there some trade-offs, right? You wrote a whole book on music, and sometimes people will say that critics oftentimes are incapable of experiencing the immediacy of a work of art because they're spending too much time interpreting it or identifying different aspects of it, whether it be historical references or structure or formal elements and so forth. I mean, is there any negative associated with just adding additional layers of knowledge to your understanding of the world? Or is this just everything gets better and richer and more interesting the more you know?
Well, I have to say I have found the latter. I mean, it's a common concern that if you look at this book on the cognition of music, I could understand a concern that if you start taking the music apart, analysing the way it's working, what's going on, and in particular in that book I'm looking at what's going on in our brains, how our brains are decoding this incredibly complex acoustic signal and turning it into something that not just makes sense to us, but that actually moves us, sometimes moves us incredibly. How does that happen? And the worry is that if you start understanding that, it's not going to happen anymore. You've atomized it. You've pulled it apart. Like an animal on a dissecting table, and it's no longer alive. I don't think that's the case at all. There's this famous video clip, actually, that of an interview with Richard Feynman, where he's challenged by the idea that science does this, that it takes things apart and ruins the mystery, and he's talking about a flower and understanding photosynthesis and understanding the colours of a flower. And he says, and I think quite rightly, it only enhances. It never, having more knowledge of what's going on only enhances. It never takes things away. This is the case that I found for music, that actually writing that book too and understanding what's going on when we're listening to music broadened my it meant that I had to listen to a whole stack of music that I'd never listened to before, but probably very often that music, because it was unfamiliar to me, it would have just seemed quite alien, and I would have struggled to find a grasp or a way in. But understanding something about what was going on in the music and what was going on in my mind as I was listening to it, again, gave me a way in. It gave me a window into it. And, I always remember with the book on pattern formation that I just finished writing that, and I'd taken myself away and I was on a beach in Wales, and it suddenly struck me. All the things I've been writing about were all around me. There were patterns in the clouds in the sky. There were patterns in the ripples that the retreating tide had left in the sand. There were even patterns or structures of a particular sort in the rugged nature of the cliffs, that they have a particular kind of structure, a fractal structure, as it happens, that, understanding those patterns actually meant that I noticed them. There were patterns in the bushes along the path going down to the beach, patterns in the way the leaves were arranged in those bushes, which I had never noticed before. And they're extraordinary patterns that you get in the arrangement of leaves in plants. So I absolutely, in that moment, felt totally enriched, felt totally surrounded by this stuff that not only had I taken for granted, I had barely even seen it before. So yeah, I've yet to find a downside to having more understanding of these things. But having said that, I was very struck when I was writing the book on music by what a music psychologist, very eminent music psychologist, John Sloboda, here in the UK, said about doing that kind of research. Because there is a danger that you start reducing our understanding of music. In order to understand how we process it, you often have to strip it down to very minimal things, very simple sort of signals, simple sequences of notes, and try to understand how people respond to them. And that tells you something, and it tells you something important and revealing. But John said that he felt it was really important for people working in his field to be constantly, I can't remember how he expressed it, but in a sense, to be constantly refreshing their memory of why they came to this in the first place, of letting themselves just be affected by the music rather than necessarily, atomizing it as soon as they started listening to it, to maintain their passion and their commitment for what they're doing. You have to sometimes allow yourself just to feel the wonder of it. And I think that's as equally true in the sciences generally as it is if you're trying to understand art or music or things that perhaps more commonly are associated with that feeling of wonder.
So is it then sort of a fluency with kind of putting on different types of lenses as you observe phenomenon in the world? It's sort of what I tell my students is like, you have a briefcase full of frameworks, and, acquiring them is the easy part. The hard part is knowing, right, which ones to use in what situations.
Yeah, I think that's a really good way of putting it. And I think that's a very useful thing to do as a scientist quite generally, to recognize, there are some scientific problems, the hardest ones really, often the most complex ones, where not only do we not yet have the answer, a theory to understand them, but I think it's very probable that there is no single theory to understand them. We will need multiple points of view to make sense of different aspects of them. In fact, actually, quantum mechanics is at the moment is like this. I mean, that's the most esoteric area of physics in some people's minds. The wonderful thing about quantum mechanics is that I think it's wonderful is that we can do the maths. We can, it's done every day. It's an incredibly successful theory that we have to understand the quantum behavior of atoms and molecules and molecular systems. What we don't know is what that theory is telling us about the nature of the world. And there are very different ideas about that, and no consensus at the moment. And I think at the moment, at least, and this may continue to be the case for as long as we know, the most productive way and the most enriching way, I think, is to hold open the possibility of several different ways of thinking about it. It feels to me as though if we decide, oh, this is the right interpretation for me, which a lot of people have, that I think risks closing your mind to other ways of looking at the problem, which sometimes might be more useful ways to attack a particular problem. So yeah, I think that fluency, that ability to put on different lenses and to remain open to different ways of thinking about a problem is one that is not just a great thing to have in life in general, but it's actually a really valuable thing to be able to do in scientific research.
And I should mention that you wrote a book on quantum physics called Beyond Weird, which I'm intimidated by the topic. When I do decide that I want to, learn about it, your book will be the one that I check out first. But this most recent book, I mean, you're doing that in this book, the Book of Minds. You're exploring a bunch of different perspectives on mind and consciousness. And, you start with the question of kind of what is mind? And I think at the end, you have some provisional synthetic view on what the mind is. But at the end, it's really, you've introduced us to a whole bunch of different schools of thought. And I think the overarching theme of the book is this idea of mind space, right? Could you talk about that? I mean, why does it make sense to think in terms of mind space and to kind of look at all of these different perspectives? I mean, I think you have a couple different 2x2s. I love these 2x2s. One that's built on Dan Wagner's and one on Christoph Koch's and one on Murray Shanahan's work. But tell me a bit about this concept of mind space, which I hadn't heard before looking at this book.
Right. Well, this was one of those books that came about through. I started to look at a very specific question, and suddenly I realized it was a very big question. So I was asked if I might consider writing an article about AI, and AI. This was several years back, and AI has suddenly changed tremendously since then. But it's still the case that actually the AI systems that we have today are black boxes. We don't really know how they're doing what they do. And there was
now, of course, this book was completed before ChatGPT-3, right, came out, and ChatGPT-4.
Yeah. So already I need to write a second edition because so much is happening and still is in this area. But this bit of research was trying to find ways of opening up that black box, and I started to try to look around for people I could speak to, experts I could speak to, as to think about this general problem of how do we open up the black box of something that looks cognitive like that. And I was getting nowhere for a long time, but I did come across a paper written right back in 1984 by a computer scientist called Aaron Sloman at the University of Birmingham here in the UK. And Aaron, in that paper, he came up with this concept of the space of possible minds. So it's not my idea, it's absolutely Aaron's. And he said, this is a way to think about minds. And he was, as a computer scientist, he was for his time thinking very much more broadly than was common at that time. He was saying, there are animal minds and all sorts of animal minds that are different from one another. We humans have slightly different minds from one another. We think in different ways. And then there are, robot minds and AI minds and others. How do we think about these? Absolutely, yeah. Very, at that time, very, very what seemed to be very simple ones. And so he said, well, maybe we should think about it as there being a conceptual space of possible minds that can exist in the universe. we don't know what the coordinates of that space are. We don't know what dimensions there are. I mean, maybe one of them is the amount of memory it has. Maybe one of them is the amount of experience it has, awareness or consciousness or whatever we want to call it. One of them is the amount of agency it has, the ability to get stuff done. So that, for example, with the computers we have at the moment, we are fairly sure they don't have actual experience as we do, but they're pretty good at solving problems. They get stuff done. So they're in a particular place in that space of possible minds. A newborn baby it seems like everything's experienced. Everything it does is just kind of intensely felt, and that's all it's reacting to. It can't actually do very much. So it's somewhere else in that space of possible minds. And, animals will be somewhere in there. And this was a fantastic, for me, a fantastic kind of organising framework for thinking about minds. And I tried for several years to figure out, what I was going to do with this. And I never ended up writing this piece that I was originally asked to look into. But it was while I spent the summer of 2019 at Harvard Medical School as a visitor there. So I was in the Harvard MIT area, which is an absolute nexus of people who are looking at these kinds of questions at the intersection of cognition, behavioral research, AI and computer science, and animal behavior. And so I started going around talking to people about this, and it very quickly became clear to me, and neuroscience, of course, and it very quickly became clear to me that this was a book that I had to write about that was kind of predicated on this idea of a space of possible minds, and looking at, well, what is that space like? Where are these different minds that we know of? Where are bats? Where are birds? Birds, I think, are a particularly interesting example, because I think that they are, unlike most animals, probably scattered widely amongst the space of possible minds, that they have such different cognitive ability, some birds from some others. Some are very good tool users, some are very good navigators, and so forth. So it provided me with a framework for thinking, let's just talk about minds. The book is called The Book of Minds, and it's trying to get a way of thinking about minds that in particular decenters us. This is the way we've thought about mind for so long. And if you read books about the philosophy of mind, they don't even say, well, we're talking about the human mind. They just take it for granted that, that's what a mind is, right? But of course, now we know it needn't be that at all. The human mind is seemingly very different from an octopus mind, and there absolutely is an octopus mind, although we understand rather little about it. And now, of course, as you say, we're having to really think carefully about, are we making minds? Is ChatGPT, does it have a mind? There are some researchers who say, well, it shows aspects of mindedness that we have, the ability to generalize, the ability to abstract what it has found from the raw data into maybe some sort of model or representation of the world. That's still controversial, whether it does that at all. And it's partly controversial because we don't have a good enough intuition of the kinds of cognition that it uses, which are different from ours. So I hope that, if anything, this notion of a space of possible minds is only going to become more and more salient, particularly as we continue to make these huge advances in AI.
Well, I think as we broaden our definition of mind, then we're just going to shift the locus of human uniqueness to something else, right? Like selfhood or something. But I wanted to ask specifically about why it is you think that, at least in recent thinking, we have gravitated towards this computational view of the mind, right? So, all the research in artificial intelligence is, primarily about computation and prediction, to a lesser extent inference, but this is really, I think, a narrow view of the mind, right? There's a lot of other things that go into the mind, but sometimes we equate the capacity to compute with having a mind, and that makes it easier for us to think of a Roomba as having a mind, right?
Yeah, absolutely. And this is something that I wanted to challenge in my book. And I think that part of the reason why we've done this is that it's what we've always done about the mind or the brain. So there's a fantastic book by the biologist Matthew Cobb called The Idea of the Brain, which takes a historical look at the different ideas that we've had about the brain, going way back. And it becomes very clear when you look at that history that, during Isaac Newton's time and, the time of René Descartes and Cartesian mechanism. And so the brain was a mechanism. It was a system of cogs somehow that we, not literally cogs that we could find, but that was basically what it was. It was just a complicated mechanism of that sort. Later on, the brain was thought of as a kind of hydraulic system, that there were, that somehow fluids flowed down our nerves and it worked that way because we had machines that worked that way. We interpret it in terms of our latest technology. And so we've been interpreting it for the last 50 years or so as a computer. And I think that increasingly we're now starting to see the shortcomings, the constraints of that idea. There are things to be said for it. There are similarities in what we do. For one thing, they're both electrical devices. They both use signals that are, sent around these complex networks. But I think that when we're thinking about mind, increasingly people who work in cognition are saying that embodiment is a crucial aspect of it. You can't expect a mind that is just computing in some abstract space to develop the kinds of resources and capabilities that the human mind has. The human mind, it's part of us as an evolved being, and the mind didn't evolve by itself. It evolved in the body, for the body, as part of the body. In fact, it's an organ. The brain is an organ, and so we understand the world as embodied beings. And partly what I mean by that is that we have a sense of things that we can do and things that we can't do that are predicated on the kinds of bodies we have. We don't have minds that are capable. One of the reasons that I think the mind of a bird will differ from ours is that a bird can fly. And so its concept of space is going to be different from us rooted to the ground and, moving in the way that we do. That's going to be different again from the kind of concept that a whale has, moving. The gravity doesn't really exist for a whale. So the kinds of minds that entities have, I think, does depend on the kinds of embodiment they have. And this is becoming more and more clear. And this is going to be an issue as we think about AI, which at the moment doesn't have embodiment, but we're talking about and already starting to build it into robotics. And I think, not only will the kinds of robotics that we use dictate the kind of mind that the AI has, but I suspect there will be a feedback process that goes on there, that that the AI mind, if you like, the AI will, maybe it will start to mutate the body. There are these robots that are reconfigurable, and the kinds of configurations they might adopt will depend on what the mind decides is going to work in a certain instance. So that's one way in which I think, the idea of the brain as a kind of computer sitting in a room somewhere doing computation, that's not enough to really understand the nature of our own minds, let alone others.
Well, you also mentioned these, I guess, organelles, right? These little multicellular things that are created from stem cells that seem to have neuronal function, right? But they don't have any embodiment, do they? I mean, they're just a bunch of nerve cells, but they're capable of stimulus and response and so forth. And you hypothesize, right? What if we were to allow these things to grow, right? It would be like a brain in a vat, right?
Well, yeah, this was actually another reason why I figured I had to write this book, the Book of Minds, because they're called organoids, and in particular we're talking about brain organoids. So our stem cells, which are cells that can grow into any tissue type in the body, we can now culture them to grow into little organoids, they're like miniature organs of our own. They're not perfect and they stay small because they don't have a blood supply, although that may change. But they, in a sense, they have a sort of intrinsic knowledge of how to structure themselves and what sort of tissues to grow into. And if we do that with neurons grown in a dish, in the right sort of medium, in a special sort of gel, so that they can develop three-dimensional structures, they start to form what looks like a little brain, like what looks rather like the sort of brain that you might see developing in an embryo, so in the very early stages. And the reason I figured, I had to include this in the Book of Minds is that I had this procedure done myself some years ago for a project that I was involved in. It was actually a project to do with dementia, and I collaborated with some researchers at UCL, neuroscientists at UCL, who were growing these brain organoids from the tissues of people who had a congenital form of dementia, which meant that they would get it early on, and the aim was to try to understand what was going on if you grew these little, they have been called mini brains, which is a bit misleading, but they're not just clumps of neurons. They have structure that looks brain-like. So I, as part of this project, I underwent this procedure myself. I had to have some basically skin cells taken from my upper arm. They were turned back into stem cells so they could grow into any tissue type, and then they were cultured into these brain organoids. So I had my own brain organoids made, and it was a strange experience, and I'm still kind of processing this notion that a bit of me has been turned into a kind of a mini brain. Now, at the moment they are very small, and although the neurons are active, they're signaling to each other as they do in brains. But we are pretty confident that when they're that small, there's no real worry about whether they should be sentient, whether they might be sentient or not. But we can't take that for granted as we get better at making these things, and we are getting better at making them. And, the better we get, the better models they are for trying to understand how real brains develop and what can go wrong. And if we can grow them bigger and give them a blood supply, we get a better model again. But the better we get at that, the more we have to think about, is there going to come a point where there is some kind of consciousness in there? There is some kind of sentience. What would that be like? Because as you say, it's disembodied. We have no theoretical way of, not even a conceptual framework for thinking about what that kind of experience, if it exists, might be like. But we're going to have to start thinking about it, and thinking about it ethically as well. What responsibilities would we then have to these mini brains? At the same time, you're right that they are, just lone objects at the moment, grown in a petri dish, but it's possible to hook them up to, if not to bodies, then certainly to other tissues. In fact, some of these mini brains have been grown that spontaneously developed two little so-called optic cups, which are the beginnings of eyes, because eyes are part of the brain in a sense. They're an outgrowth of our neural system. So this is just something that brains do, and these brain organoids started to do it. So they were light sensitive patches, and it looked as creepy as anything to actually see the images of these things, because they really are two black blobs like little eyes growing on this mini brain. So presumably they can start taking light input that way. Other researchers have grown brain organoids that they could allow to link up to bits of muscle tissue and make the tissue twitch. So they can, in some sense, control tissues. So it's absolutely feasible to think about giving these organoids some sort of embodiment and allowing them to interact with the world around them and to receive information from the world around them. What are they going to start being like once we can do that? Again, we don't know, but already we're at the point where we're having to ask that question quite urgently.
Well, it's going to be a long time before an organoid passes the Turing test, but we've already crossed that threshold with things like ChatGPT, and so that used to be a test that people held up as an important barrier, right? But I think now, even though we do have AI that can pass the Turing test, we're still not prepared to give it the designation of mindedness. So what would have to happen for these new models to be worthy of respect as being is there, what's the equivalent? I know embodied, what would it be? Minded, right? Mindful, systems. At what point, I mean, if the Turing test is not the right test, what would be the right test?
Yeah, well, I think the simple answer is we simply don't know. We don't have a test like that. I mean, the Turing test actually, quite a few years ago now, I think most of the AI and computer science community kind of abandoned it as a serious way of testing whether a system has any kind of sentience and in fact Turing, in a sense, he didn't really mean it. And so this is Alan Turing, the British mathematician, in the 1950s when he suggested this. He didn't really mean that once we had a system that could pass the Turing test, which is to say could convince a human that the responses it was giving were those from a human. He never really was arguing that once that's the case, we have to treat that system like a human being, give it all the rights and so on. He was simply saying that if we get to that point, we no longer have any grounds for saying whether it has a mind or not. All we can do is work empirically with what we can see, and we simply don't know. And in fact, I think it became clear, even in the 1960s, it became clear that this was never going to be a good test, because we are hardwired by evolution to project mindedness everywhere. It's why we do it in nature. That we've done it since antiquity, that we think the gods are angry when it thunders and so on. So we're hardwired to be gullible, to fall for the Turing test. And already, even with the crude kind of chatbots, as we now call them, that were developed in the 1960s, people were falling for this. They were interacting and thinking, is there a human operator that's controlling this? So it's been possible for decades now to fool a lot of people with even the crude systems that we have, let alone Chat GPT. So that's not going to be a good test, and perhaps never really was, other than a test of our own gullibility. But how will we decide when, if ever, these systems ought to be accorded rights, for example, or ought to be regarded as sentient? And we don't know, because we don't have a theory of consciousness. We don't have a test of consciousness that we can ever apply to other things. I mean, people are trying to find ways of probing that for animals, and I think it's widely accepted now that we should recognise a degree of sentience and probably consciousness in plenty of other animals, certainly other primates. But for these computer systems, one of the things I wanted to suggest in the Book of Minds is, when we start thinking about it as this space of possible minds, there is absolutely no reason why we should think that all roads end in the human mind. That as things get more cognitively complex, sooner or later they're going to end up with minds like ours. And in fact, I think that the likelihood is, with these computer systems that we're developing, that they won't, that they're on a different track, going somewhere else in mind space. We don't know where. We don't know where the destination would be. It may be that we could design them, if we understand enough about our own minds, we could design them specifically so that they have more human-like cognitive processes. And already people in AI are starting to think maybe we need to do that in order to make them more useful and more efficient, and to stop having these failures of common sense where they do all these incredible things, and then suddenly you ask them a question and they give the kind of dumb answer that even a 2-year-old would laugh at. So that's the problem we have at the moment, and it may be that in order to get around that problem and give these systems what we might think of as common sense, we'll have to purposely design them more like the human mind. But if we don't do that, if we just keep making them more and more bigger and bigger, and more and more complexity of interaction, I think it's by no means a given that we're going to end up with something human-like. But we might yet end up with something that has some kind of sentience, some kind of consciousness. I don't think we should take it for granted that consciousness itself is a single thing that entities have more or less of. I think it's quite possible that even octopuses have a kind of consciousness because of their very different brain anatomy, for one thing, and their very different environment. They might have a consciousness that isn't just a bit like ours, but a bit less. It might be something quite different in some respects. And I think we might end up with AI like that as well.
I think that's the key insight, that it's not a single dimension where you have more or less, but rather there's multiple dimensions to it. Last question. I think it was in the book on curiosity that you quoted Alexander Pope, and he was bemoaning the invention of the printing press because he said that it resulted in, an explosion of content that no one could possibly consume. I was wondering, what's your stopping rule? I mean, at what point do you decide it's time to stop, reading and start writing, finish writing, right? Because there's always more, right? I mean, you could have spent your entire life just adding to the critical mass book, right? Because the complexity literature just keeps developing. So at what point do you say, okay, I know enough about this topic that I'm ready to kind of move on to the next one?
It's sometimes it's simply the point at which I feel if I don't, my head is going to explode. That at some point I've just got to start getting things down on paper because, there's just too much I'm trying to juggle in here. But I think what I do find also is that certainly I think probably with pretty much every book I've written, that when I start on this journey, because it's often a new topic for me, so when I start on it, they always feel utterly overwhelming. Every sort of citation and reference that I find that looks useful, I go to it, and there are 10 others in there that I have to go and look at, and each of those has 10 others, and it just looks like an impossible task. The book I've just finished, that is coming out in the fall, called with the rather hubristic title of How Life Works. It's trying to kind of change the narratives that we tell about that question about biology. But anyway, that was one in particular where I experienced this, because if you're asking that question, where on earth does that ever stop? But I have to hope, and so far this has been the case, that there comes a point in doing all this collection of information, there comes a point where I start thinking, what, those last 10 things I've looked at, they were kind of pointing back to the stuff that I'd read before. I think I'm starting to get a bit of a feel of the shape of this area of knowledge. I don't know the details are endless, but I have a sense of what its shape is like, what its texture is like. And that's really what I have to always hope is going to happen, that there will come that point where, instead of just seeming like an overwhelming and endless task ahead of me, there's a narrative that is starting to emerge, and I start, usually I have a sense that there's something to be said, that needs to be said, and that I need to start this process of researching a book in order to say it. But I only find out what it is that needs to be said when I get to that point. Or sometimes later, after I've got to that point and when I've started writing, and then it comes. But that point has to come. I think I really, really feel that the only reason I would want to write a book about any subject is, in the end, because I felt that I've found something that I hope is worth saying about it. It's not just a bunch of stuff. It's not just saying, look at all this neat research. I hope that some kind of synthesis comes out of it.
Well, Philip, thanks so much. This book of Minds, latest book, for some people, when they read a book like this, they'll be like, well, thank God Philip Ball wrote this book, so now I don't have to read the 100 other books that he references. For other people, they'll read it and they'll say, man, I got to go and read those 100 books because they now sound so interesting. Appreciate you joining me. New book coming out in October. I'll be sure to check it out, and hope to talk again soon.
Thanks so much, Greg. It was great talking to you.
This is unSILOed, brought to you by Alumni FM, connecting people through stories.